Okay, let's talk about this Euler's method. Remember, it's pronounced Euler. Euler's method group assignment. As soon as I'm done recording this, I am going to post this video itself right in here. So when you see there's a video in here, literally this, some of you have already watched it, some of you have not. Okay, so in this assignment, I want you to do a few by hand, and then we're going to use Excel to not only check these, but to get a much more accurate result, and then graph, and we're going to include the graph. So this is the one assignment we don't have to upload a PDF because it's just, I mean, yeah, I lied to you. You do have to upload a PDF, but let's just do all this in a Word document. So like this is a Word document here. Do all your work. Like I got not a lot of space, but there's enough space that we can do our work for these. Maybe you'll want to handwrite it. I don't know. Somehow squish all those together into one document and upload it. And what I'm saying down here is you're going to create a graph. I don't need to see your Excel spreadsheet. I just want you to create a graph. And the graph comes out kind of weird here. It's got this little kink in it. I'll be able to look at it and immediately know if you did it right. And that's what you're going to insert into your document and upload. So we're going to have our hand done solutions here, and then our Excel graph from this part. Okay, so I'll do a similar problem and show you exactly what I want you to do. Make this bigger. Okay, so let's maybe do some of these by hand. I'm not going to do as many here by hand, just a couple. So let's say X and Y, and let's say our delta X here is 0.01. Okay, so we start at 0, 1. That's my initial point. And then Y at any next value should be approximately equal to Y at the previous value plus the derivative at the previous value times delta X. Okay, so we're going up by 0.01. So 0 plus 0.01 will be 0.01. Then the Y value here, Y at 0.01, should be approximately the last Y value. Like maybe I'll write this out in general. Y at the last value plus the derivative at the last value. And the derivative is a function of X and Y. So 0 for X, 1 for Y. That's my X and my Y that I'm going to be plugging into my derivative times delta X. So my last Y value was 1 plus, now I'm going to be plugging in these values into here. So I'll write this out in all its glory. 2 times 0 plus 1 times delta X was 0.01. And this one I think we could just do. We're just going to get 1 plus 1 times 0.01. I think we just get 1.01 here. All right, now my next one. All my x's are going up by the same increment. Remember, this is always delta x here. So y at 0.02 should be approximately the last y value, y at 0.01, plus the derivative evaluated at the last x and y. So 0.01 for x, 1.01 for y, times delta x. So the last y value, 1.01, plus, and then here I have to plug this x value and this y value into my derivative here. So twice the x, I need these parentheses here, twice the x value plus the y value. And that's all right there multiplied by 0.01. All right, now I'm going to get my calculator out to do this. So 1.01 plus, and then parentheses, 2 times 0.01 plus 1.01, close the parentheses, times 0.01, 1.0203. All right, so that will be this next y value that then we will use for the following y value, and so forth. Okay, now how would I do this in Excel? Well, I'm going to create a couple of columns here. I'm going to have my x value, my y value, and this guy equals 0, equals 1. You do need the equals in there. Let me make this bigger so we'll be able to see okay. Now this will equal the last one. So I click on the last one, plus 0.01. And let's go even smaller. Well, here, I'll leave this the same for illustrative purposes, and then we'll fix it later. So we'll leave that the same so we can see if we got the right values here. And maybe we'll go up until we reach 0.1. Okay, now my new y value will equal, and I'm just typing this formula here, the previous y value plus, and then in parentheses here, the formula for the derivative, 2 times, I do need the times, the previous x plus the previous y, and that's all times my delta x, 0.01. And now I can just go right here and double click right there on that little corner, and it will auto fill down. And hey, look, I got that one right. Now, what if I wanted to go a smaller 0.001? Now, it looks like it completed everything, but it probably didn't. So I need to highlight these two columns, these two rows, or highlight this row, double click again. Yeah, see, I think something changed there. But notice I'm not far enough down. Like I've only now going to 0.1. What if I wanted to go to 5? Well, I just learned this. Let me see if I can get this right. I'm going to highlight this row here where I typed in my formulas. I'm going to go to I'm trying to remember how to do this. I'm looking for fill. There, fill. Yeah, I don't know how to do this on this computer. All right, let me pause. Okay, remember everybody's version of Excel is a little different. So like your experience may vary a little bit here, but I want to go to fill and I go to series. I make sure that the row where I typed in my formulas is highlighted. I do columns, and then I do a stop value here. Let's say, let me see if that works. Nope, it did not. Let's try that again. So I did this yesterday on a campus computer. Oops. And everything was a little different. I want columns. Maybe I do need to put in my step value here, 0.001. Stop value, let's say 5. And it is not doing what it did yesterday. Let me pause. Okay, I don't know. Somehow there's a way to do it. I'm not going to make you watch me sit and play. If somebody can figure that out, send me an email. What I'm going to do here is just grab my last row here and just drag down because I know this works. And let's drag down until we hit 1. So I may have to go to like 1002 until the X value hits 1. So this we can always just drag down. There we go. And now I could graph these. So I could highlight these two columns, go to Insert, a scatter plot, and then I could come in here, go to Add Chart Element, and add in titles, labels. So here I could say, I don't know, maybe this is time in hours. I'm just making something up. And then maybe this is population of fish. And I could change my title here. Population of fish, whatever I may be graphing here. So you never ever in your life want to turn in a graph that is not labeled. Okay. And then I could just grab this. I could open up a copy of Word. I'm just going to copy and paste this nice, beautiful graph that I just produced into Word. So I've just literally highlighted it, Control C, right here, Control V. That's literally never happened in the history of doing this. Let me try that again. Copy, paste there. I don't know, something was funny there. It didn't copy right. Okay. Now I've got a nice, beautiful graph. Now, that's all for this assignment. So we're going to do some by hand. We're going to produce a nice graph. We're going to copy it into a Word document, upload it all. For your project coming up, you're going to be comparing what you get with Euler's method with maybe an exact solution or a power series solution. So I want to do something now that has nothing to do with this individual assignment. If you're just trying to do this assignment, you can come back and watch this part later. I want to do something different now. So I'm not going to need this graph. I'm going to go back, and I don't need it down that far. Let's maybe only go to, for illustrative purposes, 100. So what, this didn't even go down correct there. Okay, I'd mess something up. Let's go to here to 0.1. All right, this DE, like we could easily solve this. It's a linear first order DE. We could solve it using an integrating factor. Like we know how to solve this. But in any case, here's the actual solution. I am now going to type in to my Excel sheet the actual solution over here. So we can see that it's y equals 3e to the x minus 2 times x plus 1. So this will equal 3 times, to do e raised to a power in Excel, you do exp of something. Of what? Of my x value. That says 3e to the current x. When I'm typing in my actual solution, I'm using my current x values. And then it was plus, here we'll look at it again. Oh, sorry, I'm glad I looked at it. It's minus 2 times x plus 1. So minus 2 times, and then in parentheses, current x plus 1. Hit enter. If that doesn't spit out the same value there, if those two are not exactly the same, you've done goofed. But now I can just go over here, double click right there, and this is my actual solution. And Euler's should do a pretty good job, at least at first. Notice how close all my numbers are. If I'd used a smaller delta x, my approximation would be a lot closer to my actual value. Now, Excel's pretty smart. If I highlight all of these, and if I have my independent variable over here on the left, so it has to be in this order. You need your X's or your T's or whatever in the leftmost column. And you can go insert, and it will graph this guy and that guy versus X. And we can see they're starting to diverge a little bit. Euler's is not doing a very good job anymore. By the time I get to 0.1, even using this small delta x, Euler's is not doing a very good job. At first it is, but then they're going to diverge off. And of course, I could put labels on here. I could put a title on here, which I would want to do. But now I can find some errors. I can say, look, right here at 0.001, I just find the difference between those and say the error is very, very small. It's, 0.0000015. But by the time I get to, I don't know, here, I could calculate that difference and see how big the error is. Let me pause and make sure. I'm actually surprised they diverge that much. So I want to make sure this is all correct. I knew that error was too big. That's too much. Over here, I changed my delta x. I did not change that here in my formula for y. So when I changed this, I needed to come over here and change that as well. Now look at it. Okay, so for completeness, everything I did by hand was right. When I did a delta x here of 0.01, everything was fine. When I changed my delta x to 0.001, I forgot to come over here and change this formula in my y. It's a common mistake. We all do it. You'll probably do it in your project. Okay, now it's all fixed. Now look how small my errors are. Euler should do a pretty good job. Like, look over here. It's hardly any error at all. Look at the graphs right on top of each other. And of course, I could, if I wanted to, grab all three of these and drag down much further. See, we're starting to see a little more error there. And then I could produce another graph if I wanted to. So insert. So now I've got two graphs that I could put in my paper. One that only goes this far, one that goes 3 times further. If I wanted a graph, say, of just my X and just the actual, because in your paper for project 2, you're probably going to want that. I can hold down, let's see, I'm on a Mac and I think it's Command to only highlight those two columns. And I could do insert graph. And of course, I would make sure I labeled all these graphs. But see, now I've only got the actual versus X. And so forth. You're going to have another column here with power series, and you're going to have graphs where you have all of them on there. You're going to have graphs where you just have maybe actual versus power, maybe Euler's versus power. You're going to produce a whole bunch of different graphs. Just a little foreshadowing for what's coming with your paper. Okay, I think that's a good place to stop.